Bon, ok. Oh oui. Bonjour, hello. Sorry, it's a bit loud. Oh, hello. So, thank you for being here. Orano, one of the leaders of the fuel cycle and fuel building, is very honored to have you today. And we have a topic to share with you, which is to explain to you what sort of breadth we have in engineering services for the dismantling world, okay? So many of you might know that, but dismantling is an essential part of our responsibility of other nuclear actors. We have assets and we need to dismantle them responsibly. And also, it's very important for public acceptance that we do that. But selfishly, we all have the need to do that very economically, in time, in cost. And therefore, we have a certain number of problems to solve. And let's be honest, for most of us, it's not a main process. We are not specialists of dismantling. We're specialists, Orano, specialists of helping manufacturing of fuel. Many of you are part of electrical companies, or you're building reactors or part of reactors. You still have to decommission something, but we're not specialists in decommissioning generally. So how do we go about planning it? How do we go about estimating the right cost? How do we go about piloting it properly? It's really interesting. And for that, we all need to learn and we need help. That's what we've learned. And Orano has gathered, for very historical reasons, a lot of experience on that. And that's what we'd like to share with you today by showing you how we've done it. Okay? So it's no lessons given to the world. It's just to show you what we've done, and then you can pick, what you want out of it. We're going to do that today by showing you some examples that we have done for external customers, not our own experience. Because own experience is always a bit biased. And I could tell you anywhere what I want, you wouldn't know better. But, you can check with our customers, so it's a little bit more fair. We've selected international customers in 3 different countries, as well as 2 customers in France for today's point. I was alluding to our customers. We're really, in the field of decommissioning, reached out to many customers in the world in various fashions. Sometimes very operationally, sometimes just on engineering level, sometimes on selling equipment. But you can see big names, and it's just a small snapshot. What is probably more educative is just in dismantling, we have 5,000 people focused on dismantling. We started more than 50 years ago with our own processes, and not very long after with customer or external customer processes. Okay, the sales figure is one thing, not necessarily representative, but 5,000 people, that's a lot of hours spent every year since 50 years in dismantling. So I'm going to share first some international experience, because it's quite specific to reactor pressure vessels or nuclear power plants, and then I'll show you some of the fuel cycle facilities. Just a snapshot of where we worked in the past and still today: USA, UK, Sweden, Germany, and Asia, China, mainland, Taiwan, Korea, Japan. There's some other countries we work to, but these are the main countries where we've run dismantling projects. Sorry, wrong button. So let's start with Germany. I mean, Germany is an interesting case because the whole German nuclear industry decided to stop. 2011, Fukushima, Angela Merkel decided to walk out of nuclear. Probably rethinking today, but nonetheless, they took a decision and they decided to decommission all the reactors, point. And then also the test reactors, which are on the process right now. And then the whole waste management cycle, has to be thought about. Where do I put my waste? It's very nice to cut things, but where do you put the things that you've been cutting? It's an interesting question. Areva Backhand at that time was spun out of Areva and became Orano GmbH. So that's a little story. Why Orano? And Orano GmbH acquired 6 contracts for 7 reactors, which is roughly a third of the fleet, if you count. And we started 2017. We're still in it, and we're going to be in it until 2028, a good share of 28. So the best of most of 10 years or more, cutting reactors. We have finished quite a few. The first one fully finished is Brunsbüttel, a reactor of WNE or Vattenfall in the north of Germany, near Hamburg. And we are still finishing within the next months Mülheim-Kärlich and Philippsburg too. This is near Mannheim, this is near Koblenz. And we're going to start in a couple of months in Neckarwestheim with GKN. All these reactors for us have the same pattern. We cut the internals, we pack the internals, and with our partner, we transport them out. We don't do the reactor pressure vessel. It's in a separate contract. And we cut underwater in pools which are defueled or not defueled, different configurations, but nonetheless, we have to go cut down to the bottom, and sometimes it's 35-meter deep. And there's a lot of specificities about cutting 35-meter deep in water. First, you have pressure problems, you have waterproofness problems, you have distance, it's definitely remote. Nobody's there diving. And then you have water problems, a lot of water problems. And everything is slow. You know, how do you change a blade on a saw 35-meter deep? It's not immediate. And it's contaminated, obviously, when you pull it out. So you have to wait, and everything plays. But nonetheless, we've done it. We've done it with a lot of different technologies because in Germany, unlike in France or some other countries, you have different electricians. So here we had 3 different customers in different states of Germany, so different authorities. And we had to deal with all that complexity of different specialist companies advising the customers as well as different authorities, and all have their own way of looking at it. I mean, TÜV Nord doesn't think like TÜV Süd, and TÜV Rheinland doesn't think like the other guys, so you have to adjust. So sometimes we've been using very simple tools like a circular saw. It's not manually handled, but still a simple circular saw like you might have at home. And sometimes it's a big robot like that. This is a biggest size Staubli robot, about 1.8 meter reach, with a plasma torch or electro-erosion cutting system at the end. With all the problems you have with gas emission, recovering the gas, turbidity in the water, heating up the water, all that kind of fun that nobody thought about at the time of designing the system, obviously. But we're going through it, and we adapt. The thing is, 7 reactors, rather similar. The fact that they are BWR or PWR doesn't change a lot of things effectively. And you have to learn how to just do it better. And you have constraints everywhere, radio protection, everything I explained before. And you have to learn how to do it. And it has nothing to do with cutting technology. It has to do on how do you motivate your team, how do you plan tomorrow's work and the day after and the day after, and how do you interact with your customer. It's all about operational excellence, and that's our biggest learning in Germany because of the repeat and because it's fixed price, fixed time contracts. So we Orano had to do better, or we Orano lose money. It's motivating, I can tell you. In the US, it's very different experience. The US is much more free. You have release criteria for waste, so you can actually play around with that. And we see that in the UK, we can do sometimes the same. We started in Vermont Yankee. We acquired the plant with our partner. It's a system that works in the US. You actually buy the plant to be decommissioning. So our consortium bought the plant. And then we have the fund of decommissioning that is our limit to decommission. And at the end, it's a greenfield. It's a complete remediation. We were taking care of the reactor itself with everything inside, and our partner, all the building and primary circuit and so on. Roughly 20% for Orano, 80% for the other guys. Contracts, roughly $700–800 million a piece, huh? So give you an order of magnitude. In Vermont Yankee, it's inland. It's Vermont, north of America. You know it from Bernie Sanders. And it's inland. So you have to deal with that. You have to deal with how do I take my waste down to Texas, because the repository was in Texas mostly. And that's train. And therefore, because it's train go under bridges. So you have limitation of space, limitations of weight, limitation of contamination, and so on. And you think about the process. And you came to a cutting process which is similar than in Germany. You cut in small pieces. And you make small containers. And you transport that container by container on a train. So it made sense to use the same tooling, the same engineering as in Germany. However, when we came to Florida, Crystal River has its own harbor facing the eastern coast of Florida. So when you look far, far, far away, it's Texas. Far away. And so we thought, okay, we can do waterways. Now, waterways, you're not limited. You can build the ships the size you want. Actually, it's a barge. So then we thought, okay, why don't I do very, very large packet? Because then I don't cut so often. Now, okay, it's simple to do, to think that, but then, you know, imagine a piece, that. If that part of my computer is greater than C, class C, so very contaminated, and you mix it with something which is low contaminated, the whole thing has to be handled at a costly fee. However, if you cut it in the middle and you say GTCC that way, class A that way, you have an advantage. So you need to be really smart in how you handle your cuts. Once you've done that, so you start from the transportation. How do I transport? Size of things. Now you know the size of your containers, essentially. Now, what do I put in those containers so I have class A or exempt maximum? And if I have GTCCs, they are all in only one container. Now, you cut smartly. You put that on the side. You empty a reactor vessel. Now, you refill it with a scaffolding. And at each level, vertically, you put different class of waste. Then you pour that with concrete. You kind of remember where things are. And then you cut, you know, horizontally. And you have 3 packets. Plus the reactor vessel, 4 packets in total. And each go on the barge, 400 tons. This is about 7, 8 meter height, 7 meter diameter, steel and concrete, 400 tons. And you transport that quietly from Florida to Texas, and then on a super large truck, 100 wheels truck, across Texas, 800 kilometers, 1 month. It's not very fast. You have to actually rebuild the roundabout. You have to relay bridges. Yeah, it's fun. Yeah, well, it's 1,000 tons. You know, you don't go on the bridge like that. Oops, sorry for the bridge. Doesn't work out. So that's basically 1/3 of the reactor that you take out. You know, with the grout or the concrete inside, and it's filled with special waste inside. And then you put it in a container, a metallic container. What I try to describe here is a thought process. That's the line of my speech today. Every time we've been thinking about the situation, because Orano has a knowledge, like many others, but we do have the knowledge of what nuclear is, what the radioactivity is, what metal is, we can rethink the process thought originally and try to optimize it. And that's exactly what we've done, going from traditional cutting in Mount Yankee, because we had no other choice, to a completely different geographical situation where we could rethink the entire process and then, of course, convince the NRC to do so. In the UK, smaller scale in terms of what we had to decommission, but the same thought process. So I'm going to talk about Sellafield. And if you have a lot of questions, my colleagues from the UK are here. But for 8 years, we ran a project with our partners as part of ADAPT for Sellafield called the DDP. And the whole point was roughly to rethink the way to do things and to accelerate. The whole point of that program is acceleration. And what does that mean, acceleration for Sellafield? Just cut my stuff faster, please. That's what it means. And I'm going to show you 2 examples. Another one, here it's about the Remediation Accelerated Decommissioning Initiative. There are about 10 processes. I'm just going to talk about 2 that we were involved in. I think we're involved in 3, actually, but 2. This one is about the demolition of the turbine hall, and this one is the demolition of the blower house. Each time you have a set of challenges. I'm not going to go through the set of challenges. What was really important for us was to get a result at the end that is better than the planned result. So we can show we have accelerated. And acceleration needs to be measured by money as well. Okay? And there are different things where you can have an impact. So here, really, we've just gone faster. We rethought by using tools processes that Orano developed in other places, we could propose ways of doing it better. Here, it was slightly different. The materials that we had to handle showed trace of asbestos. And so we had to rethink how to handle materials with asbestos. And I'm going to not go too far on that because on the next slide I should talk to you about asbestos. But what is significant is we rethought the way, and we won an award on that because it was actually a new way of thinking. And that's what we did on the B14 program, which is another aspect of the project. The whole point here was to, I mean, it's a program with about 100 hot cells to decommission. It's quite a lot. And some are extremely complex with hazardous material, and some others are more simple hot cells. And Orano was tasked to find a way to do all that better. And Orano way, once described, is very simple. We said, okay, we're going to learn. Actually, it's going to be people in the cells, in hot working condition, not easy. Those people have to do better each day. So simple way to do is we start with the simplest cell. And then we go to the most complex, and the most complex, and the most hazardous. So people learn gradually. And the best practices that they've acquired in simple condition can be repeated in the most complex conditions. So this is operational excellence at its best through repetition, once again, which is very important for operational excellence. On top of it, we had asbestos problem, and here the team was very smart in rethinking the classification. Basically, and my colleagues can explain that better, but there was a difference in the way to look at the classification for transportation of asbestos and the initial classification. By reconsidering the way of looking at that and convincing the authorities, obviously very important, we could find out that actually you could consider the whole package as non-hazardous and transport it as a different way. Now that sounds super simple. Why didn't people think about it? Well, people probably thought about it, but to be able to convince authorities, you need to weigh into the conversation. You need to bring people who say, I've done it before. I know I can do it. I know how to do it. And then the authorities start to listen to you. And that's the key element. Use the relevant experience of the past with reference to convince the people that need to be convinced. Because nobody wants to make mistakes. We're in nuclear. Nobody's going to take the risk for lack of safety or security. Okay, there's not only reactors and big nuclear sites like Sellafield in the world. I'm going to show you examples on two different things, also part of nuclear power station. Those ones are in France. The first one is a legendary Super Phoenix reactor, the fast breeder reactor in France. It was a big reactor, 1,200 megawatts. It was stopped in '97, roughly, and started to be decommissioned. And here we were tasked with a rather simple task, which is to remove this. So that's a recuperation tank, the BRF. In case of the sodium tanks leak, the sodium would go there. Well, it didn't happen, so they were not contaminated. So we basically had non-radiologically contaminated metal to handle, but in a building where you need to remove everything first, and then remove the container. Very specific risk set, and particularly impossibility to work or to cut by generating heat because of the lead. Okay, so we cut without heating, which is mechanical saw. And what is really interesting in this process is it was a prescriptive design from our customer. So the customer said, you should do it like that, and we agreed to it. Once we ran through it, we found out, and there are 4 of them. We found on the first one that we were super slow, 3 times slower than we should have been. And again, we rethought the thing. And we found out that we could actually take the reservoir out as a whole piece. So on the second one, we transported it as a whole piece out, transported it on a special truck to a place where we could crush it or cut it. While we were doing that, as our team for cutting was not therefore involved, we could cut the third one and regain the time we lost. So that at the day of today, we are finishing the third one and going to start with the fourth one, and probably, let's touch wood if there is any, we'll finish the whole four exactly at the time where we should have, even though we acquired from the very beginning a delay. It's all about rethinking. But again, here, you had to convince somebody, EDF, it's not anybody, on how to do things differently from what they had thought initially. The idea was not stupid, obviously, but it was different. So people ask a lot of questions. Is it dangerous? Is it risky? What do I not see? Why would I do that? So you have to do those studies. You have to demonstrate the feasibility of those things without losing time. So you and here, us as Orano, we were late and we wasted time, so to say, trying to convince somebody, not being sure we would convince somebody in the hope to, in the end, gain time. To do that, you need to be really sure of what you know. You need to be really sure that you can convince people. In the end, we achieved the project, and I want to show you some pictures, and if you can show the movie, maybe. So this is the part where we cut it in pieces inside, and that takes about 1 month. If you're really, really agile with the cutting, it takes about 1 month. Of course, I'm going to show you the movie where you take it out. It takes a day. It's advantageous. I don't know if we can show the movie. And nice image here, you know. It's our beloved customer and our team together. It's always nice in a project to have everybody. So that's the building. It's quite a big reservoir. It's about 11 tons, I think. No, 36 tons. Yeah, 36 tons. 7 meter high, 7 meter diameter. And the transportation was about 30 kilometers. It's not very far. It does cost a lot of money, however. It's really not cheap. Because obviously you cannot drive 35 tons or 36 tons plus the truck on any road just like that, with the weeds and so on. But it worked really well. However, what's really interesting is, one could have said, why don't you take all these, if you can stop it, yeah. Why don't you take the other ones out and do the same? Because it was actually not the smartest thing to do. It was very smart to recombine cutting and transportation to reach the deadline. One should not forget the goal. And the goal was time. Oh, okay. We also removed steam generators on another NPP. You know, Fessenheim maybe is the oldest of the production nuclear plant of EDF. It's also the first one to actually go into decommissioning. It came out of, it was stopped in, not 97, it was stopped in 2020. Copy-paste from the other one. And it's already in dismantling. And we are removing some number of things, in particular, all the steam generators. There are 2 buildings, Fessenheim 1, Fessenheim 2, and they have 3 steam generators each, so it's 6 to remove. And again, this is exactly the same process we're going to apply. I can tell you we are late from the start on, and we're going to have to regain time. It's roughly the same conditions. You have asbestos, you have lead, maybe. You need to be careful. You have space constraints. You have different problems with cranes, availability, all these things, like everywhere. And you really need to rethink the whole process to be able to achieve the deadline. How you do that is, again, the same process. You come with a plan, which is the smartest based on your experience, and you convince people to do it. And you need to produce documentation, therefore. You need engineering behind you to produce documentation. So this is just starting. I just wanted to show you that. It's to follow up. And another interesting process, this one is very specific to plutonium. Maybe you know about the cryogenic treatment process. It was a very smart idea invented to handle the waste from the first, what was before Melox, I would say. and generating plutonium. So somebody came with a really good idea. It's basically you freeze the thing and you crush it, you shred it. Problem being that the mass that we put at the beginning was not exactly the same mass that we had at the end. Something was missing. And when you start to miss plutonium, not exactly, what you want to do anyway. So it was stopped early, more than 20 years ago, and started to be decommissioned. Now, this is really a very specific thing because it is extremely dense. First, it's plutonium, so you work under high alpha radiation, and you have to work in full closing. It's not easy. Extremely tight cells, fully packed. Ventilation problems. You cannot take things in a smart way out. You have to take the first things first. You need to remove the first thing to be able to take a second one and a third one and so on. And we had to think about all these things, and some of the metal cutting was extremely complicated because it's extremely dense, heavy metal, and you cannot take it out of the cell. So you basically have to bring the cutting tool into the cell. But it's a high alpha, so you don't want to have people too long over there, so you have to try to have a sort of automatic cutting tool. So we brought a diamond wire cutting tool into the building to cut the rotor. So the rotor of this big shredder, it's in itself, it's about 11 tons. And it was cut with 34 cuts into 35 pieces, which were all of a size that you can actually transport out. Today, after maybe 20 years, the site is empty. All you have is the cells empty and the walls and the concrete slab. And that obviously needs to be declassified and cleaned. But I think the project might be finished in 2 years from what I've heard. So what was the point of that presentation? The point of the presentation was to talk about two things, which are specific, at least we think, to us. That's a mindset. And the mindset is really about the culture of performance. That's what I talked about to you the whole way. It's how do you rethink every single process, even yours, so that you reach the goal? And how do you benefit from what you have to do better? The repetition, the complexity. How can you deal with that? And then you take your experience from 50 or 100 years ago, 100 maybe not, but 70 years ago as we started in France, and all these people who know all these things, and you try to bring them into the mix to convince the right people in different environments on how to do things differently. And you need to weigh in heavily. But you also need innovation. And innovation is really important. One of the key elements or key target of innovation for Orano is safety. If you cannot convince your process is safe, you're wasting your time. Nobody's going to listen to you anyway. So that's number one. Once you are convincing people you can do better there, maybe you can do the rest. So we focus on innovation for safety, and safety is everything. And it's also how people cut themselves less, how people hurt their back less. It's not just about contamination. It's really about the whole way. And then we innovate in technology. I will show you some examples. One thing to notice as well, and it might interest some people who have a startup here, but there is a venture between Orano and Supernova, reasonably well funded, to support startups who are going to innovate to meet the challenge of decarbonization. It's one of the key goals. So it's, completely at the end of that cycle, holistically. All we want to do is to decarbonize the world. That's the whole point of nuclear. Of course, producing electricity is not a bad thing in the midway, but at the end of the day, it's there. And in terms of innovation, I'm not going to tell you too much, but just raise your curiosity by showing you some pictures. Orano innovates only in fields that help the performance. We do not innovate for innovation. We're not a laboratory or a scientific outfit. So every time we bring something, it's something that has brought to us advantage in our own performance. Sometimes it's a tool to teach people better, train people better. Sometimes it's a real tool that you can sell to other people. And I invite you to come talk to me or my colleagues on the booth if you want to know more about our innovation. They are all available in the right conditions to every customer in the nuclear field in the world. So, probably took too much time. I want to thank you for your attention. And if you have any question, I'm here, and many of my colleagues for all of these nice jobs are also here. Thank you.